Good morning, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. And today we are going to discuss differential equations. So, this is about me. I have been teaching in this domain for more than 15 years, and my subjects of interest are engineering mathematics, signals and system, and analog circuits. So, these are the batches currently going on in our Gradeup platform, that is gear up batch, rank up batch, and vision batches. So you can go through the various features which are mentioned here of these batches, and as per your requirement you can join any of these batches or one or more batches. You can contact at the number given below 96500522904 in case of any queries. These are the faculties who will be dealing with the EC branch courses, EC branch related courses in our platform. Along with me, Ankit Joshi, you can see Rakesh sir, Sanjay sir, MN sir, Chandan Jha sir, and Chaitanya Reddy sir. You can feel the experience of these faculties once you join the Gradeup Super. These are our previous achievers. You can be one among them. You can take the screenshot of this frame if you are planning to join our course. This will help you in guide you. So, good morning, Sahil. Good morning, Megha. I request all of you who have already joined this session. They can just greet so that I will be able to know which all students have joined. Anyways, a very good morning to all of you. I welcome you all to this channel and this session. And today's topic is differential equation. And in this topic, I will try to give you some basic idea in this upcoming, say, 100 minutes. See, if an equation is there which is having algebraic terms, that equation will be called as algebraic equation. If there is an equation which contains only trigonometric terms, then it will be called as trigonometric equation. Whereas if an equation is involving derivatives, differential equation, if an equation is involving derivative terms, then it will be called as differential equation. So you can go through the definition. An equation which involves dependent variable, independent variable, and the derivative term is called as differential equation. Now, which type of dependent variable is involved in your differential equation? So there are two possibilities that you can have a dependent variable which is function of single independent variable x. If the dependent variable involved in your differential equation is function of single independent variable, in that case ordinary derivatives will exist and ordinary derivatives will appear in the differential equation. So when ordinary derivatives are present in the differential equation, the differential equation will be called as ordinary differential equation. Suppose the dependent variable in your differential equation is z, which is function of two independent variables x and y. In this case, partial derivatives of z with respect to x and y will exist. And when partial derivatives will exist, the corresponding differential equation will be called as partial differential equation. So depending on the type of dependent variable present in the differential equation, the nature of the type of differential equation is decided. So based on the dependent variable, derivatives will be existing, and the involvement of derivatives, involvement of the type of derivatives in the equation will make two classification, will give you two classification. If ordinary derivatives are present in the differential equation, then that equation will be called as simple or ordinary differential equation. Whereas if partial derivatives are present in the differential equation, then it will be called as partial differential equation. So these are the two classifications: ordinary differential equation and partial differential equation. Okay, so I already explained that for a function of single independent variable, simple or ordinary derivative will exist. See here, for a function of single independent variable, ordinary derivative will exist. For a function of more than one independent variable, partial derivatives will exist. For a function, it's already explained. This is the definition I already discussed. If the dependent variable involved in the differential equation, if the dependent variable involved in the differential equation is the function of single independent variable, then ordinary derivatives will exist, and such a differential equation will be called as simple or ordinary differential equation. Similarly, you can define partial differential equation. If the dependent variable involved in the differential equation is function of more than one independent variable, in that case partial derivatives will exist and they will appear in the differential equation. Such equation will be referred as partial differential equation. Now, how to determine the order and degree of a differential equation? So if you have a differential equation, in that case you have to first find out the highest order derivative term present in the differential equation. Suppose this is the differential equation. In this differential equation, there are two derivative terms, this one and this one. This derivative term is having order 1 and this one is having order 2. So you have to pick up the highest order derivative term. The order of highest order derivative term is the order of the differential equation. The order of highest order derivative term is the order of differential equation, and its degree, that is its power. What is the power of this term? The power of this term is 1, so degree will be 1. So in order to find the order and degree of a differential equation, you have to just find out the highest order derivative term present in the differential equation. If you already obtained the highest order derivative term, then its order will be the order of differential equation, then its degree will be the degree of differential equation. Suppose you are having d2y by dx square equal to under root 1 plus dy by dx whole square. One important point you need to remember, that while determining order and degree, none of the derivatives should be written in fractional powers. None of the derivative terms should be written in fractional powers. Fractional powers means radicals, square root, cube root, fractional powers. So here fractional power is involved. So it's our responsibility to first eliminate, remove the fractional power. सबसे पहले इस fractional power को, इस radical को हटाएंगे. If radicals or fractional powers are there in the differential equation, it is our duty to eliminate it. So how to eliminate square root? Squaring both sides. Squaring both sides. So if you square both sides, you will get a square here, and from the right hand side, the square root will be removed. So now the highest order term is this one. Its order is 2 and degree is also 2. So order 2, degree 2. So these are some basic concepts that you would have studied in your 12th standard while preparing for JEE or your state CET exams. Coming on to the solution of a differential equation. Basically, there are two aspects of differential equation: solution and formation. So once we prepare for GATE examination, we are focusing towards the solution. Solution means a relation between dependent and independent variable present in the differential equation. That's it. This solution must not contain any derivative or differential term, and this solution must satisfy your given differential equation. There are basically two types of solution: general solution and particular solution. If a solution contains arbitrary constants, then it will be called as general solution. So how many arbitrary constants will be there? The number of arbitrary constants present in the general solution will be equal to the order of the differential equation. Suppose you have a second order differential equation, so two arbitrary constants will appear. If you have first order differential equation, then only one arbitrary constant will appear. Particular solution: a solution which does not contain, which does not have any arbitrary constant, that will be called as particular solution. Under what conditions you will get particular solution? Sometimes along with the differential equation, they provide some initial conditions or the boundary conditions. So first of all, we find the general solution, then we apply those initial conditions or boundary conditions in the general solution. We will be getting the values of arbitrary constants, and once those arbitrary constants are obtained, they will be substituted back in the general solution. It will be giving you particular solution. So always remember that whenever initial conditions are given, you have to find out particular solution. If initial conditions are not given, it means you have to stop at the general solution. Now, ordinary and simple differential equation. Already we classified differential equation into two categories: ordinary differential equation and partial differential equation. Ordinary differential equation and partial differential equation. So now ordinary differential equation is further classified into two categories: first order and higher order. First order differential equation and higher order differential equations. So now the first order. All first order differential equations all differential equations of first order and first degree cannot be solved. Only which belongs to certain particular category, for which we have some standard methods to solve, they can be uh, solved. Otherwise, which does not fall, the differential equations which does not fall under this category, it's very difficult to solve them. Okay, so those which can be solved, which can be in your scope, are discussed here. So these are the list of those differential equations. So variable separable form, homogeneous differential equation, hey Bhagwan, linear differential equation and exact differential equation. Actually, in these free sessions, I do not get students. Sometimes there are students and there are guides as well. I want pure students, pure learners. I do not want any guides in this session. First form is variable separable form. In variable separable form, you will be getting an equation of the form f1x dx equal to f2y dy. This is an equation in which terms containing x and terms containing y can be separated on either sides of equal to sign. So if you are able to separate the two variables, if you are able to separate the variables x and y on either sides of equal to sign, then it will be a variable separable form. How to solve variable separable form? In order to solve variable separable form, first you have to separate the variables. Secondly, you have to integrate both sides. And third, you have to add appropriate constant. Separate the variables, integrate both sides, and finally add appropriate constant. See this question. Now see here. Here I am separating the variables. So x dx, this term is brought on the right side and this root will be brought in the denominator. This term side went on the other side, divided by this root 1 minus y square. So terms are separated. Now you can integrate both sides. So once you integrate, what you are getting? This square root is brought to the numerator, so its power will become minus 1 by 2 dx equal to minus sign out, sin inverse y as it is, and 1 upon root 1 minus y square. Now the derivative of this term can be produced adjacent. इसके बाजू में इसका derivative हम create कर सकते हैं. We can create the derivative 1 minus x square adjacent to it. So derivative of this bracket is minus 2x. So multiply and divide by minus 2. That's it. So the derivative of this function is written adjacent to it. So answer will be bracket to the power n plus 1. N plus 1 minus 1 by 2 plus 1 is 1 by 2 upon 1 by 2. This is the integration of the left hand side. And on the right hand side, you can see here sin inverse y to the power 1. Derivative of sin inverse y is 1 upon root 1 minus y square. So if the derivative of this function is written adjacent to it, answer will be bracket to the power n plus 1 upon n plus 1 plus some appropriate constant c. So this 2 gets cancelled. If you want, you can multiply by minus sign throughout the equation. So left hand side will become plus sin inverse y whole square, and this will become minus c. So I will replace minus c no Naga, this is not for CS students. C1 is minus c. Here also, in this question, y by x dy by dx, you can separate the terms on the right hand side. So y dy upon root 1 plus y square and x root of 1 plus x square dx. Variables are separated. Integrate both sides. Root 1 plus y square, this will be 1 plus y square to the power minus 1 by 2 dy. 1 plus x square to the power 1 by 2 dx. Multiply by 2 both sides so that you can integrate both sides. So derivative of this bracket is this one. So I can write bracket to the power n plus 1 minus 1 by 2 plus 1 is 1 by 2 upon 1 by 2 will be 2. Bracket to the power n, its derivative is written adjacent to it. So answer will be bracket to the power n plus 1 upon 3 by 2. It will become 2 by 3 plus c. This will be the answer. Take the screenshot, try this in the homework. Now equations reducible to variable separable form. This is the second form. So dy by dx equal to some function of ax plus by plus c. Whenever you get equations reducible to whenever you get a function ax plus by plus c, function of ax plus by plus c, you can substitute this equal to v. Put ax plus by plus c equal to v. And whenever you do a substitution in order to solve a differential equation, immediately differentiate this substitution with respect to denominator variable. So a b dy by dx dv by dx. So from here we can find out dy by dx equal to 1 upon b dv by dx minus a. Let us say this is our equation number 1 and you have to put all this in equation 1. So equation 1 will be giving you 1 upon b dv by dx minus a equal to function of v. And now you can separate the variables and integrate both sides. Can I have your response? You can separate the variables and integrate both sides. Please take the screenshot. In this question, 4x plus y plus 1 whole square. So you can substitute this bracket equal to v. Put 4x plus y plus 1 equal to v. Independent variable is x. Denominator variable is x. So differentiate with respect to x. 4 plus dy by dx equal to dv by dx. So dy by dx will be dv by dx minus 4. dv by dx minus 4. And this bracket is v. So dv upon 4 plus v square equal to dx. After separation of variables, you can integrate both sides. So integration of this will be 1 upon a tan inverse v upon a, where a is 2. V is 4x plus y plus 1, 2x plus 2c. This will be the answer. Here also you can do the same. Put x plus y equal to v, and the rest you can do. Take this as the homework. In this particular question, x plus 2y plus 1, and from denominator first two terms I am taking x plus 2 out, so x plus 2y plus 3. So the term which one is common in numerator and denominator, you can put this x plus 2y equal to v. So 1 plus 2 times dy by dx will be dv by dx. I request all of you to hit the like button So dy by dx will be 1 by 2 dv by dx minus 1. 1 by 2 dv by dx minus 1. So what is the right hand side? This x plus 2y, this is v. So v plus 1 upon 2v plus 3. So dv by dx minus 1 will be 2v plus 2, cross multiply this, upon 2v plus 3. This minus can be brought on the other side. So this will be 2v plus 2. Okay, you can take the LCM. 2v plus 2, 2v plus 3 will be 4v plus 5 upon 2v plus 3. Now you can separate the variables. 2v plus 3 in the numerator on the left hand side upon 4v plus 5 dx upon x. Now you can integrate both sides. So I am dividing and multiplying by 2 here. So if you divide by 2 and multiply by 2, this will become 4v plus 6. 4v plus 6. So 4v plus 6. Four v plus 6. 5 plus 1 is 6. dv equal to integration dx by x. And rest you can do, I believe. 4v plus 5 upon 4v plus 5, 1. Integration of 1 will be v. Integration of 1 upon 4v plus 5 will be log 4v plus 5 divided by 4 equal to log x. Then what? Then you will be having plus c. So finally you can substitute the value of v, that is x plus 2y, to get the final answer. Take the screenshot please. Now, what is the meaning of homogeneous function? A function having same degree in all its terms is called as homogeneous function. ऐसा function जिसकी सभी term में degree same हो उसे हम कहेंगे homogeneous function. A function having same degree in all its terms is called as homogeneous function. If you have a homogeneous function, it can be represented either as a function of y by x or as a function of x by y. See here. Suppose we have a function f of xy. Degree is 3. Yes, sir. Here also degree is 3. Here also degree is 3. So this is a homogeneous function of degree 3 because all the terms are having degree 3. Students watching this session, kindly respond. So x cube out 1, then 3 times y by x plus y upon x full cube. So if you take x cube out, then this remaining function can be written as some function of y by x. Yes or no? Yes, sir. Similarly, if you would have taken y cube out, then the remaining function will be some function of x by y. So always remember that if you have a homogeneous function, it can be represented as a function of y by x or x by y. So some 2-3 points you have to remember regarding homogeneous function. Number 1, a function having same degree in all its terms is called as homogeneous function. If you have a homogeneous function, it can be represented as a function of y by x or x by y. If some function is written in the form of y by x or x by y, then it is a homogeneous function. Okay. Now comes the homogeneous differential equation. Suppose you have a differential equation dy by dx f1 xy upon f2 xy. So this equation can be called as homogeneous differential equation if and only if f1 and f2 are homogeneous functions of same degree. For this differential equation to be a homogeneous differential equation, what is needed? It is needed that f1 and f2, f1xy and f2xy, both should be homogeneous function. Number one, both should be homogeneous function. Number two, their degree should be same. Their degree should be same. So if I assume that f1 and f2 are homogeneous functions of same degree, say n. If f1 and f2 are homogeneous functions of same degree, say x, say n, so x to the power n can be taken out from numerator, x to the power n can be taken out from denominator. So remaining can be written as function of y by x, some other function of y by x. So this x raised to n, x raised to n shahid ho gaye, cancelled, and some function of y by x divided by another function of y by x, you can write them as a single function of y by x. Yes. So this is actually the format of a homogeneous differential equation. So how to solve it? You have to put y by x equal to v, y by x equal to v. So y equal to vx. Differentiate with respect to x, you will be getting dy by dx equal to v plus x dv by dx. So equation 2 will further become, see, dy by dx will be v plus x dv by dx, and this will be f of v. Now you can separate the variables, integrate both sides, and finally add appropriate constant. See, this is the question. Dy by dx, this angle is y by x. This is an indication that we have to represent this in the form of y by x. So y sin y by x minus x divided by this entire term, x sin y by x. So y by x and sin gets cancelled, minus x and x gets cancelled, 1 upon sin. So we can say that this is purely function of y by x. So this is a homogeneous differential equation. This is a homogeneous differential equation. So what to do in order to solve a homogeneous differential equation? You have to put y by x equal to v. So this right hand side will become v upon 1 upon sin v, and dy by dx after this substitution will become v plus x dv by dx. So we can say that this v and v gets cancelled. You can separate the variables. Sin v dv minus is shifted to the left side, dx upon x. Integrate both sides. So integration of minus sin v, minus as it is, sin v integration is minus cos v. So minus plus cos v log x plus c up to the base e. Finally put the value of v. Value of v is y by x. Now in this problem, they have given this index as x by y. So this is an indication that we have to form dx by dy pattern. Okay, not dy by dx. So role of y and x will be changed. So this term is brought to the other side. So when this term is brought to the other side, what will you get? 1 plus e to the power x by y. This term is brought to the other side. So e to the power x by y. This minus will be multiplied in this bracket. Now you can work out the value of dx by dy. So this will be e raised to x by y, x by y minus 1 upon 1 plus e raised to x by y. And now you have to put x by y equal to v. X equal to vy. Differentiate with respect to y. So dx by dy, v plus y, dv by dy. I differentiated it following the product rule. So this is equation 1. Do the substitution. This dx by dy, can be written as, क्या लिख सकते हैं भाई? Tell me. This is v plus y dv by dy equal to e to the power v minus 1 upon 1 plus e raised to v. Great. So this v should be brought to the other side. V e raised to v. V is brought to the other side. So minus v, take the LCM. Minus v e raised to v minus v upon e raised to v plus 1. So this v e raised to v and v e raised to v gets cancelled. E raised to v plus 1. Minus is taken common from these two terms. V plus e raised to v in the denominator, dv, dy in numerator, y in denominator. So variables are separated. After separation of variables, what you have to do? Integrate both sides. So what you are getting? क्या दिखाई दे रहा है आपको? Derivative of denominator is present in the numerator. Derivative of v plus e raised to v is 1 plus e raised to v. So this can be written as log of the denominator. Right hand side is minus log y. And appropriate constant will be log c. So you can take anti-log. And finally you can put the value of v. Value of v is x by y. So after putting the value of v, that is x by y, and then taking the LCM, we got the answer is x plus y e raised to x by y equal to c. I request all of you to hit the like button. That is the only source of boosting for me. Okay. Another thing is you need to keep on responding. Yeah. Now comes the linear differential equation. So linear differential equation means an equation in which I am telling you how to mathematically identify linear differential equation. Dependent variable and derivative term should not be multiplied together. Dependent variable and derivative term should not be multiplied together. That is the meaning. Okay. So if dependent variable and derivative term are not multiplied together, it is called as linear differential equation. dy by dx plus py equal to q. This is say type A, and type B will be dx by dy plus px equal to q. So dy by dx plus py equal to q. In this, y is dependent, x is independent. Here x is independent, y is dependent. X is dependent and y is independent. So the role of dependent and independent variable is different in the two equations. That's it. P and Q are always functions of independent variable. P and Q are always functions of independent variables. So here they are functions of x and here they are functions of y. Then we have to find integrating factor. E to the power integration p. P is function of x, so dx. integrating factor here will be e to the power integration of p, but p is function of y, so dy. Now solution of this equation: dependent variable into integrating factor, integration of q into if dx plus c. Here the solution will be dependent variable into integrating factor, integration of q into if dy plus c. So these are the solution formats that you have to remember. You can take the screenshot also. Done. Now see here. This is a differential equation. See, dy by dx, this is e to the power minus 2 root x upon root x minus y upon root x. So there are two terms on the right hand side. Now which term should be brought to the left hand side and which term should be brought to the right, should remain on right hand side? So what you have to do, in type A we have dy by dx pattern. Krupal, yes, this is very important for all branches except CS. For computer science, this topic is not in their GATE syllabus, but for all other branches, this is very important topic. So dy by dx equal to one term, another term. So we have type A, dy by dx plus py equal to q, where q is function of x, correct? So on right hand side, terms containing x are allowed, but mixed terms, that is terms containing y, are not allowed. So this format guides us that this term is not allowed on the right hand side. So we will be bringing this term to the left hand side. Julie Kumari, good morning, beta. So I got this pattern. Now I have got P and Q. What is P here? 1 by root x. What is Q? E raised to minus 2 root x upon root x. Now IF, e to the power integration P dx. So IF is e raised to 2 root x. Now we can find solution. Solution is Abhijit Mitra. Good morning. Solution is dependent variable into integrating factor, integration of q into if dx plus c. Integrating factor is e raised to 2 root x. Q. What is q? Q is e raised to minus 2 root x upon root x. if e raised to 2 root x. So these two terms will get cancelled. Integration of 1 by root x is 2 root x plus c. This will be the answer. See this term. Here number of terms in the denominator is more and number of terms in numerator is less. So you have to take the reciprocal. So twice y log y plus y minus x upon y. Now you can separate the terms. So 2 log y plus 1 minus x by y. So this is type B. In type B, the pattern is dx by dy. Right hand side is q, which is function of y. Function of independent variable. Yes. So right hand side q is allowed, that is terms containing y is allowed. This term is not allowed. So this term is brought to the left hand side. So dx by dy plus 1 upon y into x equal to 2 log y plus 1. So now you can say that this is P and this is Q. You can find IF and then you can find solution. So I have just arranged this differential equation so that you can proceed further now. Do it by your own. I request all of you to hit the like button, share the link, subscribe our channel. Now equations reducible to linear form. See, all equations cannot be reduced to linear form. Those can be reduced are here. See, f dash y dy by dx plus p times f of y equal to q. So what you have to do here, this middle term, see this middle term, in this middle term function of dependent variable is y. Put f of y equal to v. Differentiate with respect to independent variable x. So f dash y, and according to chain rule again differentiate y with respect to x and dv by dx. So you can see that f dash y dy by dx is dv by dx plus pv equal to q, and which is nothing but a linear differential equation. Now you can write the integrating factor as well as you can write the solution. But remember here the dependent variable is v. So the given differential equation is non-linear as the dependent variable and derivative terms are multiplied together. But after doing this substitution, this is reduced to linear. If you interchange the role of x and y, you can get type D. That will be f dash x dx by dy plus p times f of x equal to v. And how to solve this? You have to substitute this equal to v. Can I have your response? Can you please like the session? Now see this question. Now in this question, we are getting a dy by dx pattern. In dy by dx pattern, right hand side is q. Right hand side is q. Right hand side is q. And q is function of independent variable. Here independent variable is x. So terms containing x are allowed on the right hand side. But this sec y is not allowed. Are you getting my point? In dy by dx pattern, right hand side q is the function of x. So this sec y term is not allowed. Divide by sec y throughout the equation. So 1 upon sec y cos y dy by dx minus 1 upon 1 plus x tan y divided by sec y will be sin y 1 plus x e raised to x as it is. Okay. Now derivatives coefficient is dependent variable function, means it can be reduced to linear form. So see the middle term. In the middle term, this is your f of y. F of y equal to sin y. If you put this sin y equal to v and differentiate with respect to x, so derivative of sin y will be cos y dy by dx equal to dv by dx. Yes, so cos y dy by dx is dv by dx minus 1 upon 1 plus x. Sin y is v and right hand side is 1 plus x e raised to x. Correct? So now you can say that this is linear differential equation with p equal to minus 1 upon 1 plus x, and this is q. Are you all following? So if, find out the if. E to the power integration of p dx. E and log gets cancelled. 1 upon 1 plus x will be if. After getting this if, proceed for the solution. So solution will be students please respond. Dependent variable is v, integrating factor q into if dx plus c. Dependent variable is v, if is 1 upon 1 plus x. Q, what is q? Check it. Q is 1 plus x e raised to x. If is 1 upon 1 plus x plus c. Now v is sin y upon 1 plus x equal to this 1 plus x cancelled. Integration of e raised to x will be e raised to x plus c. So I already substituted the value of v. This is our final answer. So sin y equal to e raised to x plus c into 1 plus x. This can be a final answer. Hit the like button. Hit the like button. Like button hit कीजिए. Stay tuned. Stay tuned for some more beautiful concepts. This question you can try your own, dy by dx. So there are many questions available here for practice. You can take the screenshot. I will move to the next variety. Most welcome beta. Dx by dy will be xy plus x square y cube. X square y cube. Okay. Now we have two terms on the right hand side. Dependent variable is x. So which term is having greater power, larger power of dependent variable x? Obviously this term. This term will be written on right hand side and this term should be taken to the left hand side. The term which is having larger power of dependent variable should be taken on the right hand side. That's it. Now it is dx by dy pattern. Right hand side q is the function of y. So this term is allowed on the right hand side, but this term is not allowed. So divide by x square. Divide by x square both sides. X upon x square will be 1 by x, and here you will have 1 y cube, only y cube. Okay. So coefficient of derivative term is the function of dependent variable. See the middle term. This is our f of x. Put this equal to v. Differentiate with respect to y. So minus 1 by x square dx by dy equal to dv by dy. So 1 upon x square dx by dy will be minus dv by dy. 1 by x is v equal to y cube. Multiply by minus sign throughout the equation. So we can say that this is p and this is q. Now you can find out if. This is if. You can proceed for the solution. Solution. Dependent variable v, integrating factor e to the power y square by 2, integration of q into if, q if dy plus c. So you can integrate this. You can integrate. Of course, you can integrate. Put y square by 2 equal to t. Here. So y dy will be equal to dt. So after this substitution, you will be able to integrate this. Okay? Yes, sir. Try this. Try the integration. Requesting all of you to hit the like button. Yes, completed. Then, till now we have covered variable separable form, equations reducible to variable separable form, homogeneous differential equation, linear differential equation, and equations reducible to linear form. Now comes exact differential equation. So if you have an equation of the form m dx plus n dy equal to 0, then this equation will be called as an exact differential equation if del m by del y equal to del n by del x. If del m by del y is equal to del n by del x, then equation 1 is exact. And if this equation is exact, then its solution is given by integration of m dx over y constant plus terms of n not containing x dy equal to c. This is the format of solution. See, this is of the pattern m dx plus n dy. So here m is, this is m. Partially differentiate m with respect to y. So twice x plus 1 minus sec square y. Derivative of twice xy with respect to y is twice x. Derivative of y is 1. Derivative of tan y is minus sec square y. Take minus common. Sec square y minus 1 is tan square y. This is n. Del n by del x. Derivative of this term with respect to x. This will be twice x minus tan square y. So both of these terms are same. So we can say that this equation is exact. If this is exact, solution is integration of m dx over y constant. Integration of m dx over y constant. This is m, 2xy plus y minus 10y. Plus terms of n not containing x. So this is n. The terms which contain x, skip those terms. Skip it, skip it. Oh, this is free from x. So consider it. Equal to c. So y is constant. So twice y constant. Integration of x will be x square by 2. Then y minus 10y, both are constants. Integration of 1 is x. Integration of sec square y is tan y equal to c. You can cancel this 2. So this is how we get the solution of exact differential equation. You can try this also. The following differential equation has, okay, you have to tell what is the degree and what is the order. So here order is 2, should be t. Order is 2, highest order term is this one. Order is 2, degree is 1. Order 2, degree 1. Order 2, degree 1. Option B. Hmm. Is there any fractional power? No. No. So order 2, degree 2. Order 2, degree 2. Higher order linear differential equations. Higher order linear differential equations. So higher order linear differential equations, can be classified into two categories. One with constant coefficients and another with variable coefficients. So this is the format of higher order linear differential equation with constant coefficients. Here you can see the coefficients are constant, a0, a1, a2, an, these are all constants. So you can abbreviate them as f of d into y equal to capital X. This can be the format. So here dependent variable is y, independent variable is small x, and capital X is the function present on the right hand side. Capital X is function of small x. No. F of d into y equal to capital X. This is the format of LDE of higher order with constant coefficients. LDE of higher order with constant coefficients. LDE of higher order with constant coefficients. So its solution is CS equal to CF plus PI. Its solution is CS equal to CF plus PI. CS is complete solution, always denoted by dependent variable. Here the dependent variable is y. CF is complementary function. It contains arbitrary constants such as C1, C2, C3, etc. PI denotes the particular integral. It is a part of solution whose evaluation process depends on the function present on right hand side, that is capital X. So this is the method to find CF. There are some 3-4 steps for finding CF. First you have to write the given differential equation in D form, that is called a symbolic form. So that is, you have to write the given differential equation in this format: f of d into y equal to capital X. After this, in this f of d, you have to replace d by m and equate it to 0. So this will be your auxiliary equation. So write the given differential equation in D form, write the auxiliary equation. So this auxiliary equation will be in terms of m. So when you solve this auxiliary equation, you will be getting the roots in terms of m. So according to the nature of roots, we have to write CF by following these cases. First one is write the given differential equation in D form. Second one is write the auxiliary equation. Third one, find the roots of auxiliary equation. Fourth, what you have to do, according to the nature of roots, you have to write the complementary function. So when roots are real and distinct, 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 in that case, CF can be written as C1 e to the power m1x, C2 e to the power m2x, C3 e to the power m3x, where m1, m2 and m3 are the roots of the auxiliary equation. If there are two roots, say m1 and m2, so only two terms will be there in this CF. If there are three roots, three terms. If there is only one root, then only one term will be there in the CF. Case 2, when roots are real and equal. When roots are real and equal, then suppose three roots are real and equal, then C1 plus C2x plus C3x square, and outside we have e raised to mx. When roots are complex, it will be having this nature, alpha plus I beta. So e raised to alpha x, C1 cos beta x, C2 sin beta x. When roots are complex and repeated, suppose you are having one root which is alpha plus minus I beta. There is another root m2 which is also alpha plus minus I beta. In this case, CF will be e raised to alpha x, C1 plus C2x, cos beta x, C3 plus C4x, sin beta x. So d4y upon dx4 plus 4y equal to 0. See, here the right hand side term is 0. So when right hand side term is 0, pi will be 0 because pi depends on this right hand side term only. So we have to write the auxiliary equation. We are adding and subtracting this term. So m square plus 2 whole square minus 2m whole square, a square minus b square. A plus b, a minus b equal to 0. This is one, this is another part. Then roots will be minus 1 plus minus I, and for here roots will be m equal to 1 plus minus I. So roots are complex, and you can say not repeated. So you will be applying case 3 for this and for this. So CF will be alpha is minus 1, beta is 1. So e raised to alpha x, C1 cos beta x, C2 sin beta x, plus same root for this one, e raised to x, C3 cos x plus C4 sin x. Since right hand side is 0, pi will be 0, this CF will be the complete solution. So complete solution will be CF, y will be CF. Copy this. Whatever is the answer, since last 20 years this is the answer. अब बदलेगा नहीं, आंसर नहीं रहेगा. d4y by dx4 plus 8d square plus 16 into y equal to 0. So m raised to 4, 8m square plus 16 equal to 0. So m square is square, 2m square into 4 plus 4 square will be 0. So m square plus 4 whole square equal to 0. So m square plus 4 equal to 0 and m square plus 4 equal to 0. So you will be getting m equal to plus minus 2j and m equal to plus minus 2j. So for this case you will be getting complex roots and repeated. So here alpha is 0, beta is 2, same is the case here. So CF will be e to the power alpha x, then C1 plus C2x cos beta x, C3 plus C4x sin 2x. Right hand side is 0, so complete solution will be only CF. Two j and minus 2j. M minus 2j, m plus 2j, this will be m square plus 4. These are the roots of this equation, but we needed the roots of this equation. अंतर है ना दोनों में? ठीक. Try this question. So you can try this question. Okay, so I'm having another session in few minutes from now, so we'll be winding up now, and I will plan, if at all it is possible for me, I will plan one more session for this higher order linear differential equations. Okay, and attendance is needed, response is needed. So if that is not at par, I will stop these sessions. Okay, anyways, we'll try to plan one more session to complete the higher order differential equations. We already into the process. So cases, and there are 6 cases to find pi. There is one more method called as method of variation of parameter to find pi. So that can be discussed in some other session. Thank you. Take care. Tomorrow's time is 9 a.m., but topic may be different.